Back again, and welcome back to another video. And this is going to be another component that we're going to be integrating within our framework. And it's been something that is being requested by a couple of you guys. So I've been putting together over the past couple of days a small migration script that we're going to be implementing within our framework that's going to help us migrate tables to our database. Now, there's a lot of different migration scripts. A lot of them do a lot of things differently. In this particular framework, our migration component is purely going to be migrating our database table to our MySQL database. And without further ado, I'm just going to jump straight into the component. I've got my screen set up right here. I'm going to actually go through the files and the scripts. I'm going to walk you through the code that's actually doing the work, and I'm going to do a quick demonstration also in MySQL to show you the process of how we actually migrate our database tables to our database. So without further ado, I'm going to jump straight into the code base, and I'm going to show you the folders and structure that I've got set up, and what my idea was of how I want to create this script. So let me take it to the app directory, because everything happens in the app directory. And you can see, if you've been watching my videos so far, you'd have seen that we've got a structure, and it's the same structure that we've stuck to. So down in this app directory, I've got a new directory that I've created called migration, and it's empty at the moment, but this is going to be where all of our generated migrated files is going to be stored. And unlike some other small script, we're not going to be creating these migration files from scratch. We're going to actually be creating some schemas, and then we're going to have them generate those migration files for us. Now, if you've been watching from the very get-go, from the very start, I touched on a couple of stuff, and even though I didn't actually go through this particular component, I did touch on it, and that is my schema component. At the moment, it's just a directory with some schemas in, and what I mean by schemas is our database table. So we can build our database schema, and we can have our migration script convert that to a SQL statement for which we can then push, or for which we can then migrate to a MySQL database. So I got a schema directory within the app directory, but I've also got a schema component within the core directory, and I'm going to actually show you what that is doing, and show you how it's linked to the well, it's not physically linked. There are two different components, and what they allow us to do is to create schemas and then convert those schemas into SQL statement, which we can then migrate to a MySQL database, if that makes sense. So I'm going to show you a schema from one of these, within one of these files, and bear in mind that the structure of how we create our schema is all the same, and that is for consistency. So I'll open up one of these files, and I will show you exactly how we go about creating the schema. So I can pick any one. I'll just pick the more complicated one, which is going to be the user schema, right? So this is the user schema, and this basically is going to create the SQL code that we need to migrate to our MySQL database, which is going to create that users table. So I'm going to quickly show you my local setup, my local MySQL on my PHP admin, and I'm going to show you that it's quite empty at the minute, and where we're going to be pushing these migrations to. So if I switch my screen and I go to my MySQL database, or my PHP admin portal, you can see I've got a database that I've set up. It's called Lava CMS. It's empty at the minute. It says no tables found. So I've got no tables set up in that at the moment, and we're going to be generating all the migration files and pushing it to our MySQL database. And I'm going to walk you through the process so you can see how that happens. So get back to my main screen, And let's just have a little walk over what this particular file is doing. And like always, I always start with strict type declare at the very top. We've got the namespace, which is the app schema, which is the directory that we're in the app directory, and we're now within that schema directory, and that is our namespace. That is how we locate or include this particular file if we want to use it, right? So these are all dependencies that we're bringing in because we need all of these other components in order to sort of like build up our schema. Now, a good point to note is when you're creating a schema class, it's always good to name it sort of like we're creating a model. Like you got a user model, we're gonna have a user schema, so we know that this particular class is related to a users table, right? So first thing we do in our schema is we're implementing a interface, and that interface contains one method at the moment, which is this create schema method. And don't worry, I'm going to bring you through all of these different files. I'm going to show you what they're doing, right? So we're designing by interface, and we're forced to create or assign a contract stating that we're going to be implementing this single method. So that's what the interface is doing. It's allowing us to create that one method which is going to be used within our migration script to print or to capture the return of this method that we're going to be using to generate our migration files, right? So this is our basic implementation of a schema file. We got a class, we're calling this user schema, we're implementing the data schema builder interface. I know it's a bit of a long name, but it's named accordingly. Well, there's a purpose behind all the naming, so you're not confusing in what you're actually implementing, right? So we got 3 protected properties. We got and they're all type inted, right? So we've got a data schema, we've got a data schema blueprint, and we've got our user model, because this user schema is related to our user model, right? It's not linked, it's just related to our user model. And I'm going to show you how we're going to be using that user model object to get some methods within that user model class that we're going to be using to help generate certain strings for us. So we get a constructor, and you can see that we're type inting our classes, or we're type inting within our constructor, because this particular, well, all schema is being loaded by our container. So all these classes is going to be it's going to be auto wild for us because we're loading it, or our schema classes is being loaded through a dependency, through dependency injection, right? So all of these are going to be instantiated for us, and we simply just sort of like piping them to these properties that we've declared up top, so we can then use them within our class. So again, all of our schema objects or schema classes contains this one method called create schema. It's got a return type of string, because that is effectively what is going to be returning a string, right? So what we got going on right here, we can see we've got a lot of chaining going on. There's quite a lot of chaining going on, and it, don't be put off if it looks confusing. Trust me, it is not at all confusing. Once you understand how chaining works, it's pretty simple what I'm doing. And I'm not quite sure, I can't remember if I've actually show you the first iteration of this schema class. I haven't got one at the minute because I've deleted all of them, because I'm going with this new schema type that I've implemented. So I'm not quite sure if I did show you the old implementation where we pretty much didn't have these blueprints, and it was pretty much a case of returning a schema type as an array and defining all of the attributes that were needed for that particular field. But I've done away with that. Well, I said done away with it. I have not done away with it. What I've simply done is I've created a blueprint class, and I've simple just created these little method that implement those array, and so I create some sort of abstraction. So it's a lot more simple to use in your schema classes to just call these methods. And you got two required arguments. Well, some might have one required argument or some might have two, but the first argument in each of these methods is always going to be the name of that field, the name of the field in your database table, right? That is always going to be a required field or required argument in any of these method, right? So the blueprint contains a lot of these little helper method like varchar, int, you got text, long text, tiny text, datetime, all the stuff that you will create or implement when you're writing SQL code. But what this is allowing you to do is not touch any SQL code. We're going to be using straight PHP to implement those SQL codes. So even if you've got no SQL experience, you don't need to, because I've pretty much done it in a way that you don't really need to know SQL code. You could pretty much create your schema just like what you see on your screen, and it will generate that SQL code for you, right? That's just one way of doing it. You don't really need to use this schema. You could pretty much write your SQL code in your migration script and just let it do it that way. But I think this is a neat way of doing it. I say so because I created the thing myself, so I liked it. I've been playing around with it all day today just so I can get to grips with it before I do this video, so I can show you guys how it works, right? So this is the structure for a SQL code, a structure for a schema, and it goes like this. So we've got this schema, which is the first class that we've implemented within our constructor, and this brings us to our schema component, and within that schema component we've got a bunch of method that we can chain. Oh well, I say a bunch of method, I think we've only got about 5 or 6 method that is chainable, and the last method in the chain is this build method, because that returns the string that we're creating from the method above in the chain, right? So I'm going to walk you through what each of these methods are doing, and then I'm going to show you the code structure that I've created that is allowing us to implement all of these chainable method. So the first one is the object that we've called in this schema, and the first method is the schema method, and what that does, it takes in an optional argument as an array, which we can then use to modify, for instance, the database engine, default char set, etc, etc. If you leave it blank, it will just simply use what I have set as default, and I will show you that later on as well. So that's the first argument. The second argument is the table, right? And that, well, I call it table, and that effectively takes in the actual model object as its only argument, and that is all it's doing, right? Internally, what it's doing with that object, I'm going to show you what it's doing, right? So the third method in the chain is row, and what the row allows you to do is to create as much rows as you need in your database table, right? You can see for users table, we got a lot of row. We've got first name, last name, email, gravatar, status, etc, etc, etc. So we can add as much row we need, for the database table that we're creating. And the last method on this chain is that build method, which actually returns all that we've created up here. And I said there was about 5 methods. There's actually 4, and it's 1, 2, 3, 4. There's 4 method that is chainable that we're using to create our schema, and our build method actually accepts I think it's a callable or callback function. And you can see what we're doing with the callback function is we're declaring an anonymous function within the build method, and we're simply returning additional stuff that we need for our query. So stuff like adding primary key or setting unique keys. And the last method that we call on this particular mini chain is the add keys, and that will simply concatenate all that we've set right here and return it as part of the larger query that we've set above, right? That is pretty much all it's doing. It's creating that query for us that we're building, and it's going to return a string that we're going to convert into a SQL statement, which we can then migrate to our database. So if I can show you different schema classes. They're pretty much all the same, apart from the different roles that we're setting for a particular table. You can see we've got a different database table called remembered login, and this takes 3 rows. We've got a auto-generated ID, which is something I've not touched on, but this auto ID essentially just returns a integer column or integer row for us with a length of 10, and it's an auto incremented row. So we can simply just pass auto ID, and it defaults to ID, right? It defaults to ID, but if we wanted to call our primary key something else, like for example UID, we can do that, but by default it will use ID, right? Which is mostly how most of my tables are set up, with a primary key of ID. So I've just set that as default, but if you wanted to call your IDs or your primary key something else, you can just put that value within this particular method, this auto ID method, just like so, right? And something else I've not touched on is we could add a primary key. We could add a primary key but as a string, for example. We could, add it just like that, or we could do what you can see right here is get primary key, and what that effectively is doing, or what that is effectively doing, is getting whatever we've set within this auto ID, and it's simple returning it within this method, which we can then use to add a primary key to our table, right? And set unique key, we can set unique key if we've got multiple unique keys per table. We can set it as an array, or if it's just a single unique key, we could basically set it as a text, as just a string. So we can say token hash, and that will work. Again, some table might have multiple unique keys, like for example the user schema. You can see that we've got multiple unique keys. We've got email, password reset hash, and activation token, which is all unique keys for this particular table. We can set all of them as an array, right? Or if we've only got the one key, we can just set it as a string, and it will work just the same. So that's the basic schema. As I'm saying, I've got 1, 2, 3, 4, 5, 6, 7 schema created. That's 7 tables, and the structure is all the same, with the difference being the fields that we're adding and the model that we're linking to, right? Obviously we're going to be changing the name to represent what schema we're trying to create migration files for, right? So that is our schemas. So I'm going to go ahead and show you some of the core components that we're using to build up these schemas. So if I close this down, let's go into the core directory and let's find that data schema component, which is this directory right here, data schema. So we open that up. You can see we've got quite a lot of files. We've got a couple of directories as well, a couple of subdirectories as well. And again, if you've been watching how I've been coding, I've been trying to keep consistently a similar structure throughout all my components, where I've got a exception directory which contains all of my exception classes. When I'm throwing exceptions, I like to put them in a separate directory. And if I've got traits, which I always try and use traits, because again, it's a PHP. It's not a class. It's a PHP file that allows you to extend or create methods which extend a class, method that we can then use throughout a lot of different classes, something like that. And so I like to try and implement traits wherever possible, right? And you can see I've also got a types directory, and this contains the different what we'll say SQL query types which we can use. Like for example, we got a lot of different types on the string. We got a lot of different types on the integers or numbers. We got a lot of I'm going to show you exactly what I'm referring to, but this is the actual structure or the file structure of this component, and the main ones that I'm going to walk you through first is the actual data schema itself, and then I will show you other bits that makes it up. So the data schema interface is what I want to get on the screen next. Data schema interface is this particular class, and these are the 4 methods that I've just walked you through, and they're all part of the interface, right? The data schema interface. And you can see we got a schema, we got table, we got row, and we got that build method which accept that callable, that callback function, right? And the row that's got a mix type. This is all PHP 8 as well, so we can now use this mix type within our arguments to declare our arguments, and we've got that set for our row. And the reason why I've done that actually, because initially it was just an array, and I think I've just been messing with creating different types, and I don't think I actually changed it back to an array. I've left it as mix. Well, hopefully I'll be able to declare a different type of arguments within that row. Again, I'm messing around with it at the moment. You don't need to change it. It can stay as a mix argument for now, because it works just the same. It won't affect the way it works. But yeah, it was an array before, and I've changed it to mix, and I can't remember why I've changed it to mix. But again, I might change that back to an array, because that's effectively what we're passing in, and what that blueprint object is passing in is an array, right? So never mind that for now. And we've got a table which accepts that object, and it's going to take in a data model, right? And a schema which accepts an array, and the argument is overriding schema, because we can effectively override the default schema that we've got laid out, right? So that's the interface. And what I normally do when I've got a lot of files like this is I've created an abstract data schema, and that's where I've implemented that interface, right? So within the abstract data schema, it's not a class that we can instantiate. We don't want to instantiate this class. So we're doing a lot of like the validation logic in this particular class, which we can then use in the main data schema class. But I say it's quite boring. There's not a lot going on within this particular abstract class. In other components, I've got quite a lot going on, but for this particular component, there's not a lot going on apart from some validation. And this is a schema attribute which is being concatenated onto the end of our query string, which is all gonna get passed to our MySQL when we're sort of like trying to migrate that table to our database, right? Hope that makes sense. So this particular abstract class isn't doing a lot. You can see we've defined, or we declare, a protected constant which got all that default schema that we've got. So this is the default engine is InnoDB. We've got a row format set to dynamic, and we've got the char set, and we've got the collate set by default. So with every table that we migrate, this is what is going to get migrated with that database table. Again, we can override that within the schema method within our schema class that I showed you earlier, or we can leave it blank and it will simply just use what I've set as default, right? We got empty constructor at the minute, I did have something in here, but I said I'm messing around with it. For the time being, I'll leave it. So when I come to extend or build upon this, that might become useful, right? And again, we've just got some validation, and we're validating that schema. So if you pass in an invalid argument, it's going to throw an exception. So again, I've not filled it out fully. I've just simply put in some default, and it will just check against these. And if you've submit some or input something that doesn't match what I've got in here, then it's gonna throw this data schema invalid argument exception, right? Same thing for the char set and the row format. When it comes to the collate, there's a lot of it. I might just take this option out because I don't particularly want to list all the different collates within my code, because it just wouldn't be a good use of my time, put it like that. So that's the abstract data schema class, and it's one that implements that data schema interface. And if I go to the main data schema class, you can see we're extending that abstract class. So effectively, we're going to be forced to implement all those methods that we've got within that interface, right? Within the abstract class, we don't have to implement them. But if we're going to extend that abstract class, we're going to have to implement them in the class we're extending, the class we're extending to, which in this case is the abstract data schema, right? So I've gone ahead and I've declared some properties which is not being used in this particular class, but is being used within this data schema trait, right? So I've declared properties, and then they become valid properties that I can use within this trait. So again, got an empty constructor. I did have something there before. I can't remember what it was, but I want to leave it there because eventually when I come to build out this component even more, I might be able to use it. And we got the schema method. This is the first method that we came across within that schema. If I bring that back up, you can see that's the first method that we come across, schema, right? And by default, we can leave it empty because we've declared an empty array, which means we can just leave the method empty and it will just use all the default setting that we've gave it. And you can see we're sort of merging the arguments with the default, and if we're saying if the method is empty, then just use the default as what we've set right here. And we're doing a for each loop over those overriding arguments, and we're checking that it's valid, and if it's not, we're going to throw an exception. And you can see we'll return this so we can then chain onto the next method within this particular class, which is going to be table. And that takes in that data method or a data model, and we sort of like pipe it to a property within this class. And this is like a setting method. So basically setting a property to that object that we've passed in. So now within this class, we can use this data model to access any method within our models class, right? So the third method is this row, and you can see we got a mix argument which is set to null, and we effectively checking the argument is an array, because it could be an array, it could be any data type. That's why we set it to mix, because it could be anything, right? So we're checking if it's an array. Yeah, so we're going to get all of those, or we're going to create a for each loop over those arguments, and we're going to create objects from them and get all the settings or all the attributes as option. So we're creating a new object, and we're passing all those attributes as the arguments for those particular objects. And I'm going to show you what this looks like. I mean, it might not look much to you at the moment because you're probably sitting there scratching your head, what's going on here? You can't really see what it's doing. But I'm going to show you exactly what these objects look like and what the options are that we're passing in. I'm just simply saying if this object is not an instance of the data schema type interface, then we're going to be throwing an exception. So all of our objects must implement an interface, which is a data schema type interface. It must implement those, or else it's going to throw an exception. And you can see we're simply just passing or storing those objects as an array, right, into this property, and we're returning this. So our returning the object so we can then chain on our last method onto it, which is that build method, right? And you can see we're checking if this property that we've created up here, we're using it down in our build method, and we're going to iterate over it, and we're going to be calling a particular method in one of those, well, in all of those objects, which is a render method, right? And we got a callback function which is doing what's this doing? This is doing callback, which is doing doing the constraints. If we're adding constraints, we're gonna be concatenating that result onto the end of onto our database query, right? Which is effectively what this is going to be returning. You can see the first element that we've declared is that create table if not exists, and I'm sure you've seen it before. When you create a database table, this is creating MySQL code for us, right? So everything in between is going to be all those rows that we've declared within our schema classes, and it's going to pretty much just return each one that we declare as part of that structure that we're building to migrate to our MySQL database. So that is effectively what that build method is doing. And don't worry about that for now. I was simply messing around. So I'm going to be, I said, the migration script at the moment is only able to migrate tables to the database. But in terms of dropping tables or altering tables, that is still something I'm creating as I'm building this video. But that bit is not quite ready yet. So I will touch back onto that once it's finished. Hopefully I'll get it done tonight and I can touch back onto it in the morning, right? So that's effectively what our data schema class is doing. It's got 4 methods which is helping us to build that schema that we need to migrate, or that schema that we need to create our migration scripts that we're going to be using to migrate those tables to our database. So again, I've got all these updated on GitHub. So if you can go there, you can clone it, download it, whatever you want, and just sort of like just go over it and try and grasp or try and get your head around what it's doing. Because I promise you, it's very, very simple. Once you get your head around it, it's dead simple in what it's actually trying to do, right? So that's the that's the data schema component. That's half of it. The next bits to it is stuff like the blueprint, and that's got an interface as well, and it's empty at the minute. What I tend to do is, unlike some developers, they might sit down and they might have a bit of time to plan and plan and plan. I haven't got time like that. Sorry, I have not got that kind of time. So I tend to get a idea in my head and I try and build it out, and then I do an interface and then put those methods in the interface and say, yeah, that's exactly how I want it to be. And then I'll modify as I go along until I find that I'm satisfied with where I'm at. I haven't got time to sit down and make plans about how I'm going to structure it. I pretty much just got an idea in my head and just jump on it and just build it as I go along until it makes sense. It might not be everyone's way of doing stuff, and it's not always my way of doing stuff. I mean, I do plan things at time, just not all the time. And this was one of those components that I just sort of like chucked out. And initially I built it and I didn't really add no use for it. I don't know why I built it. I just built it. And now I've got the migration script that I've been writing for the past 2 days. It's sort of like clicked in, like, yeah, I can use that schema to generate some migration files, and then I can use those migration files to create my database tables. So it all came together in the end, and yeah, that's how it is for coding. Sometimes it comes together, sometimes it don't, right? So got interface for the blueprint. I will be putting these methods into that interface and just tidying up a bit, tidying it up, putting some dot blocks, so it sort of like explains a little bit more of what those methods are doing. And I'm big on dot blocks. I think you need to document your code, despite what everyone says. I think, whether it's yours or someone else, a little bit of documentation will never hurt. That is my view on it. I don't go with people saying don't document this, don't document that. I like to document because even I'm forgetful at times. Sometimes I come back and I can't remember what that code was doing, even though I wrote it. So a bit of documentation does go a long way. So I will be doing that. But you can see I sort of like was rushing through it. I had the idea in my head and I just wanted to get it out. So the blueprint helps us to quickly add those methods that's going to generate the row for us without us having to create those arrays and listing out all those attributes, right? This is what this blueprint is doing for us. I've created these so it becomes much easier to just quickly create the row that you need without, writing out long arrays. So stuff like varchar, you can see I've got, even though it's got quite a lot of arguments, the only argument that is really required is the first one. The rest of them is optional because I've set defaults. For the length, for a varchar field, the length I've set at 196. That's default, right? You can change that if you want. The third argument is a boolean, and it's called null, and I'll set it to false. And what that does is it basically say I want this field to not be null. It's a required field, right? If you want it to be a null field, you can set that to true. Set the argument to true, right? And we got a default field. Again, it is set to null by default. You don't need to use it because it will just be none, default to none. If you want to set a default on that particular field, you can. So you can see what I've done. The only field that is really required is the first one because that is always going to be different for all your rows, right? And it's pretty much the same for all the different methods, arguments, set defaults, and it just allows you to just quickly use the blueprint object, grab a method that's going to print the row that you want. And you can see what it's doing. It's using those string types, classes, and we got all the attributes. Now this is what I was doing in my first iteration of the schema, but I've done away with that. I've pretty much just returning them in methods, which we can then use out in our application schema to quickly generate the row that we want, right? So that is all that is doing. As you can see, I got tiny text, I got long text, and this is by far very minimal. There's a lot of different fields in MySQL that I could use, but these are the most common ones, right? I will be creating more, but these are all the common ones that we use on a daily basis. Integers, date, time, and I've got some default sets. Again, guys, it's very simple. I'm gonna be putting some documentation. As you can see, I've documented some. I will be documenting all of it, so you've got a better idea of all the settings that you can use for each of these methods. So that's the blueprint. And as I mentioned about that auto ID, again, you see I've set the default to ID and a default length to 10, right? And that is it. You can override that name if you want to, but you always leave it at 10. Again, I've seen no reason to change your ID from 10. I've always seen it set at 10, so I've just gone with that. And in that set primary key or add primary key method, which, where is it again? Let's bring it back up. Add primary key, right? Add primary key, and we're using this blueprint to get the primary key, and that's a simple thing that I've done. And you can see we've got a set primary key which we are calling within this get or this auto ID, which is simple taking that first argument as the argument for this set primary key method, which is going to be ID. So if we override that, it's simply going to pass down to this method, which we're then returning in or get primary key. So it doesn't matter what we set, we're always going to get that string within this method that we then call in within that schema class. Very simple, very simple. Again, yeah, but that's all the blueprint method for now. There's obviously going to be a lot more, but these are all the common ones that we can use to build out any database table that we want, right? So if I close these two files down, what else have I got? I've got the base, right? So this is the class that handles the concatenation of all the different rows together, right? And you can see we've got all the different columns that you come across in a PHP admin, for example, when you're creating MySQL or database tables. These are all the different columns you come across: the name, type, length, collation, attributes, null, default, index, auto increment, and comments. Now I've listed them out in a protected constant called schema columns, right? And I've got two properties, one's types and one is row. And you can see I've also created a constructor, and I've basically checking that we've got all the rows, and we're merging those rows to our schema type. And again, we're doing more validation of all the different columns that we're using within all of our type classes. And I'm going to show that in a minute and show you exactly what it's doing. But you can see for the method that we're using, well, we've got get schema types, which is simply going to return this property as an array. Get schema column, which is just returning this protected constant as an array, which you can then use somewhere else, because as you can see, these are all protected constants and properties of this particular class, which we can't use or we can't access outside of this class. So we're simply returning them in methods that we can then use somewhere else. And again, we're returning the row, which is also a property of this class, and I'm going to show you exactly what they're doing. And the method that I mentioned in my schema class, that render method, this is that render method, and it's simply just taking all of the name, field, length, attributes, default, and concatenate them together and just returning them, right, on their own lines. And I'm going to show you what that looks like when I generate a SQL or generate a SQL migration file. You're going to see what it looks like, right? That's pretty much what it's doing. So this is the base type. So all of my subtypes is going to extend this base type and rewrite some of these methods. And this is also designed by interface, and I've got that data schema type interface right here, and it simply start those 4 methods that I've just walked you through a while ago. Let's get rid of that. That's not being used. So that is the database schema base type. And if I go onto my types, and the one I'm going to show you is a string type. And this is my string type. It extends that database schema type, and it implements a database schema type interface. Now that's the interface that I mentioned earlier, that if you don't implement that interface, it's going to throw an exception, right? And that was coming from, get that class back up, and that was coming from this row method. So we'll create the objects, which is these objects: string type, got JSON type, numeric type, and date type. These are the objects that it's creating, right? And it's passing those row as the arguments, which is being passed back into that object right here, right? Because that's effectively what they are. They're all attributes that we're passing back into the object constructor, which is what we've got access to right here, the rows, right? And we're simply passing that down to our parent constructor, which is going to be our data schema base type. So if I bring that file back up, data schema base type, you can see the first argument is that row, right? And we're passing that down into that parent construct. All this row, all the row that we've set. Let me show you exactly what these rows are. So if I go back to our blueprint, these are what I'm referring to. All these information, all these attributes get passed back down into the constructor. That's what we're passing back, right? So we got the object and we got the attributes. So we create the objects and we pass these attributes into the constructor, right? Which is what I'm doing right here. I've created a new instance of the object and I'm simply passing those attributes back into the constructor. Just like what we got right here. The object and the attributes, I've called it row, but it's really attributes into the constructor. And we're passing that down to the parent construct, which is going to effectively use all the attributes for this particular object type, right? And the second argument is the type, which is what we've passed or what we've declared as an array, a protected array within this particular string type class. Now these are all the different types, all the different string types and I got these from MySQL. I didn't create these myself. These are all stuff you can find if you open up PHP admin. These are all the different string types that you can use. I mean, I probably won't be using all of them. The ones I'm using at the minute is varchar, text, tiny text, and long text. I will implement some others, but I probably will not be using all of them. But I declare all of them as set out by MySQL, so you know all the different string types you can possibly use within MySQL or PHP admin, right? So that's all it is. And for the render method, I'm simply just calling that parent render because I don't need to do anything within the string type apart from calling back that render method within this render method. Simply just calling the parent render method because I can use a parent render to render what I'm doing in here. And again, date type, these are all the different date types. Got date, datetime, timestamp, time, and JSON. Again, I did not create these were all set up by MySQL. I simply just adapt them within my project. And so we got all the different date types that we could possibly use. And the only one I've created at the minute is date time, or not date type, date time, which is what you would use in most tables to sort of like get a timestamp or a current timestamp of when you create an item within your database. And again, the process is the same. We're returning that row for that datetime object, attributes as the row, pass that back down to the parent construct, and we're passing that second argument as this types, which is going to put this types into that parent construct. And again, same jobby, returning the parent render, because again, I don't need to do anything in this class. The base type render is all being done right here. It's all being done right there. There's nothing else I need to do in any of these classes. Unlike my form builder component, I've got a similar setup, but only difference is You got different types, and like for example, you got your input type, or input type is the base type, and under that you got like your checkbox, radio, you got text, numbers, range, etc., etc. In that component, I'm actually modifying the render method, because even though all these types that I've just mentioned come on the base input types, some of their structures are a little bit different. But with these, the structure is the same, so there's nothing I need to do apart from just return that base type, right? I hope that makes sense. Again, I've not done the form builder, the form, what you call it, the form builder component with you guys yet, because it's quite a long one. It's quite a detail. There's quite a lot going on, right? And I've got a lot of different types, as you can see right there. But not to dwell on something different, we come here to do the migration and schema components. So let's just try and focus on that. So that's all the type. I've got date type, numeric type. Again, all the numeric type that we can use, and the ones I'm using at the minute is the int, which stands for integer. Again, there's a lot of different ones that I'm going to be implementing, but for the time being, I've just got the most common one that we use all the time. And again, same jobby, constructor, role, and types, and the render. That's all we're doing. And JSON type is a new one. I haven't got a lot of information on this particular type just yet, but you can see I've got a protected array of types, which is empty, right? I've not really done much on that one, to be honest. When I do, I will come back to this one, but I haven't got a use case for this, so I'm not too bothered about this one at this moment in time. So that's the actual schema. It's very, very simple in what it's doing. It's allowing us to create our database roles, which we can then use our migration script to generate for us a SQL code from that schema, which we can then migrate to our database.